In this lecture, we'll go over linear equations and the rectangular coordinates. We'll interpret the line graphs. We'll write a solution as an order pair. We'll decide whether a given order pair is a solution of a given equation. We'll complete the order pair for a given equation. We'll complete the table of values. And we'll plot the order pair. Let's get started. Let's first start with interpreting the graph. Let me get the pen here. As you can see, this is your x-axis right there. It's showing you the number of days. Day 1, day 2, day 3, day 4, day 5, and day 6. Here we are looking at the temperatures in the New York City. This represents the y-axis, which is the degrees in Fahrenheit. As you can see from the graph that the 67 is the highest temperature that it reached on day 6, and 43 is the lowest temperature was on day 1. Every time you see that the line is going up means the temperature is rising. Except I see that from day 2 to day 3, you see there's a temperature drop. From 53, it dropped to 50. Every other single time you see the line is moving up means the temperature increased. You can find the difference of the temperature. Say, for example, from day 4 and day 3, there is a difference of 2 degrees Fahrenheit. The highest difference I can see is from day 1 to day 2, because from 43, it right away jumped to 53. So this is just a small information that you can gather if you're looking at any graph, which is going to give you a lot of information. Let's talk about the linear equation in a two-variable. It's a standard form. A linear equation in two-variable is ax plus by equals c. It can be in this form or it cannot be, but it has to be make sure that a and b cannot be both 0. The reason why, because if there's 0, the variable is gone. If there's no variable, there will not be an equation. So we prefer this form ax plus by equals c. Let's write a solution as an order pair. A solution of a linear equation in two variables requires two numbers, one for each variable. For example, a true statement results when we replace the x with the 2 and the y with the 13, and the equation is y equals 4x plus 5. So in this case, I'm going to replace my x by 2, and I'm going to replace my y by 13. So therefore, I'm writing everywhere where it says y13, and everywhere where it says x, I'll put the 2. So this will give me 13 equals 4 times 2, 8 plus 5. And therefore, both the sides are coming to be true. This is happening when I'm replacing my x by 2 and y by 13. So that's called an order pair. It's very important what number goes first. You always want to put your x first, followed by the y. So x values always goes the first and y value always goes in the back. That's called the order pair. So in this case, this order pair is actually the solution because both the sides are coming out to be true. Let's try a few more examples. Here's another example. This time the equation is 5x minus 2y equals 4. First, we're going to try with the order pair 2, 3. Remember, what you will replace your x by is your first number. X will be your 2 and y will be your 3. So to see whether 2, 3 is a solution, let's substitute 2 for x and 3 for y. So here I write 5 times 2 minus 2 times 3. Is that equal 4? That's what I'm interested in knowing. Now 5 times 2 is 10 minus 2 times 3 is 6. That should give me 4 equals 4, which is true. Therefore, 2, 3 is the order pair for this equation as a solution. It will work. Let's try other order pair for the same equation. This time my order pair is -2, -3. To see whether this -2, -3 order pair is working, I'm going to replace my x by -2 and I'm going to replace my y by -3. Let's replace 5 times -2 minus 2 times -3. Will that equal 4? We'll see. That's giving me -10 plus 6. -10 plus 6 equals -4. And that is not true. -4 doesn't equal 4. And therefore, -2, -3 is not the solution. This order pair will not work for this equation. So we saw the two examples for the same equation. Only one is working. The other order pair is not working. So to remember, in order for it to be work, it has to be true on both the sides. If it's false, the numbers don't match, then it's not a solution. Now let's complete the order pair. Here's an equation. -3x plus y equals 4. So the order pair is given 3, the second number is missing. So we know that the x is 3, but we don't know what the y is. So we will replace our x by 3 in order to figure it out the y. Let's go ahead and substitute the x for 3. So I'm going to write -3 times 3 plus the y, which I don't know, equals 4. -3 times 3 is 9. -9 plus y equals 4. This is a linear equation. So we want the y alone, so we're going to add the 9 to both the sides, +9. And that will get rid of the 9's, and then y should equal 13. So in this case, if my x is 3, my y must be 13 in order for the 3 and 13 to be the solution. Now let's try the b where the y equals 1 and the x is missing. So in this case, we will replace the y by 1. So we'll substitute 1 for y and let's solve for the x. So we will write -3x plus 1 equals 4. Subtract the 1 from both the sides. -3x should equal 3. Let's divide both the sides by -3. That should give you x equals -1. So your order pair, the one which works, will be x is -1 and y is +1. Let's try the same idea when the table is given. The equation is x minus 3y equals 6. It's given to you in the table form. In the first one, the x is missing, and in the second row, the y is missing. Let's first start with the first one. The y is given -1, the x is missing, so we'll figure it out that one first. So go ahead and replace your y by -1. So x minus -3 times the y is -1 equals 6, which will give me x plus 3 equals 6. Subtract the -3 from both the sides. X equals 3. So for the second order pair, now let's put the x equals 12 and figure it out the y. So 12 minus 3y equals 6. Subtract the 12 from both the sides. That will give us -3y equals -6. Divide both the sides by -3. That should give you y equals 2. So therefore, the table is complete. When we had the y equals -1, we got x equals 3. When we had the x equals 12, we got y equals 2. So this is your order pair, 3, -1, 12, and 2. Now let's learn how to plot the order pair. 1, 5. Remember your x is 1 and your y is 5. So if you look in the number line, we are on the x-axis. The right side is a positive, the left side is a negative. And on the y-axis, on the top, you have a positive numbers, and then the bottom, you have a negative numbers. So if your x is 1, we are looking at the right side, 1. And then we'll go 5 up. So if you can see that green dot, that is 1, 5. You move 1 step on the right side and the 5 steps above. So that is 1, 5. -2, 3. -2 is on your left side. So you will go -2 to the left first, and then you will move 3 steps up. So this point, the red dot, is your -2, 3. Let's try a few more. -1, -4. -1 is on your left, but this time the -4, so you will go 4 steps down. So your purple dot is your -1, -4. 3, -2. 3 is positive, go 3 places to the right from the 0, and then go 2 below. So that's 3, -2. 3 over 2 and 2. Now 3 over 2, if you change it in decimals, 1.5. So 1.5 is between 1 and 2. And then you will go 2 steps above. So you will be in the center. So first I go between 1 and 2 in the middle, and then go 2 steps above. 5, 0. So 5 is on your right. Now 0 means you're not moving up or down, so you will be staying on the x-axis. Let's try one more, 0, -3. So 0 means you're not moving up or down anywhere, but the -3, you will go down below on the y-axis. So this is your 0, -3. So this finishes the lecture on how to put the order pair and how to find if it's the order pair is a solution or not.